Mrs. M. Priyadarshini, ME MBA, is doing PhD, is currently working as teaching fellow in the Department of IST, Anna University, Chennai. She completed a Master's in Software Engineering from Anna University. She has about 10 years of experience in handling courses for UG and PG. She was serving as Technical Evangelist for Corporate over 4 years in Java Enterprise Technologies, Software Engineering, Databases, OOAD, and Design Patterns. She is proficient in handling IT projects as well into concept development for enterprises. She is doing a research in the area of web services security. Her other areas of interest include software engineering, OOAD, databases, enterprise technologies, and service-oriented architecture. She holds many journal publications and conference proceedings in her research area.
Welcome to UGC lecture series in Computer Science, Java Part 8. So in previous sessions, we have seen about various input stream classes available in Java I/O package, and in this session we are going to see about the output streams that are available in Java I/O packages. They are class hierarchy and then few demo programs. So output stream class is an abstract class that is used for reading 8-bit bytes of data. The subclasses of output stream class are illustrated as following. So we have already seen that input stream class is an abstract class which has various inherited input stream classes. Similar to that, for your output stream also we have a abstract class, and then we have a set of inherited classes from that of your output stream classes. So this is used to read bytes of data. So already in your previous session we have seen that we have two types of streams. One is byte stream, another one is character stream. So your input stream and output streams comes under the type of byte streams, whereas your readers and writers comes under the type of character stream. So now we'll see the class hierarchy of the output stream. So we have output stream. From your output stream, all the other output streams are inherited. So this is abstract, so we know that abstract class for which instances could not be created. So here we have file output stream, which is used in order to write the contents to a file. So next is object output stream, the contents written in form of objects. Piped buffer output stream, and then we have filtered output stream, and then byte array output stream. So filtered output stream is inherited as data output stream, buffered output stream, and then the print output stream. So first we will have a look on what is byte array output stream. So byte array output stream is an implementation of an output stream that uses byte array as the destination. This class has two constructors, one is without arguments and other one with number of bytes. So this byte array output stream class is going to handle, or it's going to be used in order to write the contents into a byte array. So we have two types of constructor here, one without arguments and the other one with number of bytes that you are going to write inside the byte array output stream. So here is a sample program, byte array output stream. So we have a main method. In this main method we have IO exception. So this IO exception is also available in your IO package. So byte array output stream instance is created here, and we have a string here. Then we are trying to get the bytes of the string that we have given as string S. So now we have a byte array, the set of bytes of this particular string. So now in that particular output stream, I am trying to write the value that is available in this particular byte array. So now I am converting that into string and then displaying it to the user, because we have converted that into form of bytes. So this is in byte array. Now in order to display that, I am trying to convert that into string format and then I am displaying it. And then here you can see byte array f.toByte array. So here this is a stream which is converted into a byte array. So now I am printing that character by character. So my byte array contents is printed as characters. So here you can see that output stream F2. So this is the base class and your new file output stream is the derived class. So this F2 is nothing but an object of the base class, whereas the instance that I am trying to equate to is the derived class, that is your file output stream. So now F2 is being typecasted. So your file output stream will be typecasted with the name of F2. So now I have given a file name and then f dot write to F2. So it means that I am trying to, F is nothing but our byte array output stream. So here f dot write to, I am writing that into a file. So that is file output stream. So both are here output streams. So and then after that I am closing my file and then I am resetting that particular byte array. I am closing here, I am closing the file output stream, whereas here I am resetting my byte array output stream. So and then I am trying to write few other contents. So I am writing xxx for here we have an for loop which prints 3 times this value, and then after that I am printing it using the toString. So as well as my byte array, now my byte array will be printed in form of string. So you can see that our output stream, byte array output stream, is going to handle the byte array. So we have methods which could be used in order to convert the contents into string, into byte array. All these are methods that is available in your byte array output stream class. So next we are going to see about file output stream class. So file output stream class is used to write bytes of data to a file existing in the file system. So file object or file descriptor object is used as an argument to represent the file to which the data is written. So in your previous example we have seen file output stream, and then we have also seen about your byte array output stream. So the behavior of file logs while using this class is dependent on the underlying operating system. So how the logging is done, when I open a file, when I close a file, when I read the contents from the file, when I write the contents to the file, the behavior is decided based on the operating system, the underlying operating system which is used. So this class extends the output stream. So here we have a demo program. So you can see that I have an instance of file output stream and then I have an instance of print stream also. So now I have a string and then I am having a buffer reader. So buffer reader, anyway we will see that in your forthcoming sessions. Anyway now I will state the purpose of buffer reader here. So buffer reader is going to read that is your system.in, nothing but your keyboard. So keyboard is your system.in. So I have already told you that you have system.in, system.out and then system.err. So these are variables that is available in your system, that is in your java.lang package. So here it means that your system.in means that your default input device. So that is nothing but our keyboard. So from the keyboard it's connected to input stream reader, the datas are moved to input stream reader, then the datas are moved to your buffer reader. So here I call buffer reader dot read line method. So this will read an entire line, that is it will read the contents till the end of the new line character, and then it is being trimmed and then it is stored in str text. So now I am getting the length of it. So I am getting the contents till length becomes 0. Now I am, what is my out? Out is nothing but my, you can see out is nothing but my file output stream. So here I am creating a new file output stream with the file name being given, and then I am having a print stream. I am creating a new print stream. This is connected to my file output stream. So now my print stream is created with a parameter of my file output stream. So now I am printing these string contents into that of my print stream. So now this print stream is connected to this file. So automatically the contents goes to the file. So I am closing and then I am coming out. Here I have a common exception. I didn't catch IO exception. It's common, so it catches all the exceptions. So maybe your file not found exception or maybe your IO exception. So you also have a filter output stream. As the name suggests, it is used for working on an output stream by manipulating the output data based on the certain filters. So we can filter based on particular conditions as defined by the user. So the filter output stream class also extends the output stream. The filtering conditions can be based on various conditions. So, what conditions? Such as writing only ASCII characters or writing the characters in the specific range in that of the string. So, next is our buffered output stream. So, buffered output stream class enables output stream to buffer the data bytes that are written. So, whenever I write the data bytes, so I can buffer it using my buffered output stream. So, the data is written in the other streams are usually not buffered. Hence, we have to access the disk for writing every byte of data. Buffered output stream is also a subclass of your filtered output stream. So, buffered output stream maintains an internal buffer array wherein bytes are written from this string. The data is collected in this buffer until it gets filled and returned to the output string. So, it means that the data is collected in the buffer till it gets filled, and then only it will be written into the output string. So, output may be anything. So, we can write this into a file or we can write it to any device, whereas in the middle we have a process called buffering. So, the data, each and every byte of data will be passed on to the buffered output stream, and then that will be buffered entirely, and then it will be written on to the particular output which has been directed, which it has been directed. The data that is written onto the buffer is also written onto the output sink, where the buffer is flushed explicitly or the stream is closed. It means that, so the data is written to the buffer. It is also written to your output sink when the buffer is flushed explicitly or the stream is closed. So, whenever I am trying to explicitly flush my buffer or I am trying to close the stream, the data gets entirely filled in the output sink. So, next is about data output stream class. So, data output stream class enables an application to write primitive data types in the machine independent manner. The data output stream class extends your filter output stream. The data written by this stream can be read into Java program by data input stream. So, already we have seen that there are two types of data. One is primitive data and other one is non-primitive data. So, primitive data is all basic data types like int, float, double that is available in your Java or any other programming language, whereas non-primitive data types are like objects. So, it means that I am trying to have an int as a form of an object called integer. So, we have already seen in that in case of wrapper classes, I wrap the basic primitive data type and create a non-primitive data type, or else even other objects like employee, your salary class, your student class, all these classes are instantiated as objects. Okay, those comes under your non-primitive data type, whereas your data stream handles only primitive data types. So, there will be methods corresponding to your integer, float, all primitive data types. So, this stream helps you in writing your data, primitive data into a particular device or to communication media or so. So, we have a demo program here. You can see here in the main method I am trying to have set of arguments, 2 arguments. So, now I am trying to have a buffer. So, this buffer size I am going to have or read it from integer. Integer is nothing but a wrapper class. ParseInt is nothing but a method which passes the argument 1, and then argument 1 value is being converted into. So, it means that your first argument is your buffer size. So, next I am trying to create a file output string. So, we will have a short break and we will continue the session after the break. Welcome back after the break. So, now we are going to continue with our program related to data output stream. So, as already I told you, so here we have integer, a wrapper class, and then I have a parseInt method which is going to pass the integer, that is my args of 1, and then it is going to state the buffer size. So, now file output stream, and then this args of 0 is nothing but the file name. So, now I have a buffered output stream BOS. So I am creating this buffered output stream with a constructor in which I give the file output stream name and then my buffer size. So then I am going to have a data output stream. This data output stream is in turn, this data output stream in turn takes buffered output stream as the parameter. So now whatever the contents I write into my data output stream will be written into buffered output stream and then into the file output stream. So now you can see that I am trying to write integer I, some I value. So here it's from 65 to 91, I am trying to write this value. So then I am trying to print that. So here this is ASCII value of your characters. So this will be converted or typecasted into character and will be printed. Whereas while I write that into my data output stream, it will be written in form of integer. So after writing all these characters, just I am closing my data output stream. And then here we have file not found exception. So in case if the args of 0 file is not available, just it will print that the file is not found. And then in case of my buffer size also I raise an exception. So here you can see that illegal argument exception means that my argument is not properly given. So it means that my buffer size, whatever I enter, cannot be 0 or negative. So next we are going to see about printstream class. So the platform's default character encoding is used to convert characters written using printstream to bytes. So it's more useful when characters rather than bytes are to be written. So here this printstream could be used when characters has to be written. So here the platform's default character encoding is used to convert your characters written into bytes. So we know that stream itself means that it's in form of bytes. So printstream class extends the filter output stream class. So next is our piped output stream. So piped output stream class is a subclass of our output stream class again. Usually it works in combination with piped input stream for a communication pipe to be created. Declaration of this class is as follows. So public class your piped output stream extends your output stream. So here piped input stream will be communicating with the piped output stream. So it means that I am trying to create a communication pipe through which your data from your piped input stream could be read and the data inside your piped output stream could be written into. So there will be a communication between these two types of streams. So next we are moving into reader classes. So as already I told you that there are two types of streams. One is your character stream, another one is your byte stream. So far we have discussed about the byte streams. So now we are entering into discussion on our character streams. So as character streams, the class names will be represented using reader and writer. So whenever I say about the reader, so the reader means that it is of type character. So the data that will be written, it will be, if at all it is a writer, the written data will be in form of characters. If at all it's a reader, the data that we read will be in form of characters. So the objects, even if it is being connected with reader, so then automatically that will be converted into characters. So reader is an abstract superclass for the character streams that are used for reading characters. Abstract class reader provides the API along with partial implementation for all reader streams that are used for reading 16-bit characters. So now we are going to see the class hierarchy, that is the subclasses of all the reader classes in this figure. So here we have a reader. So this is base class of all the other classes, your buffer reader, your character array reader, your input stream reader, your file reader. So your buffer reader is inherited into your line number reader. So then your input stream reader, you have a file reader, and then for your file reader we have pushback reader. So the buffer reader class here maintains an internal buffer of characters and hence enables streams to read characters, lines, arrays and strings efficiently. So we already know that what is the use of a buffer. So if your device, you have two devices, your input device, your output devices. So in that case, if you are not able to maintain the speed of one of your device, and then the other device. So in that case we have an intermediate buffer which could handle the data. So your buffer reader class is used for the purpose of reading your data efficiently. So whenever I try to read a particular data, if the data is already buffered, it will be easy for me, and then the time for reading the data will be reduced. So this will give an increase in the performance. So the buffer size can be specified. When the buffer is unspecified, the default size is used. So I can specify the buffer size. If not, the default size will be used. The buffer reader class extends your reader class. Your base class is reader class. It means that you could handle all the character streams. So here we have a demo program. So here I have a file reader and then a buffer reader. So this buffer reader is communicated with this file reader by giving your file reader as the parameter for constructing your buffer reader. So now this file reader is again created using a file name. So it means that from this file I am going to read the contents character by character. So here data is equal to buffer reader dot read line. So this is what is difference between your file reader and then your buffer reader. So from your file reader, each character by character is being read, whereas from your buffer reader, if you want to read, you can read it in a particular buffer size. So it means that it may be end of the line or a particular buffer size. So here we have used br.readline. So if at all I have the contents, so then it would be printed. So then I am closing my buffer reader as well as my file reader. So already we have told that whenever you open a reader or writer, whatever the classes you have, so it should always be closed. So we have catched an exception called file not found exception. So this will be raised when the file you are trying to read. So here we are using it as a reader, file reader. So if your file is not found, this exception will be raised. And then here we have IOA exception. So IOA exception is the base exception for all input and output. So next is line number reader class. So this line number reader class can be used in case of current line number of the data being read is to be kept track of. So if I need my line number to be kept track of, in that case I can use this type of reader class. So for example, I want to have a count of number of lines that is read, or if I have a restriction that only these number of lines could be read or written into a file. So in that case I can use this line number reader class and then perform the or calculate my line numbers, and based on the line numbers I can continue with some particular operation. So this again extends the buffer reader. So next is our character array reader. So character array reader is used for reading characters from an array of characters. So this is going to handle character array. So this again extends the reader class. So next is our filter reader. So filter reader, as the name suggests, it's used for filtering the data you read. So already we have seen this filtered streams, filtered input stream we have seen, filtered output stream we have seen. So based on particular condition, if I want to filter the data that comes across my stream, I normally use this. So similarly, whenever I try to read a set of characters based on some conditions, if I want to filter it, I can just use filter reader class. So this again extends the reader class. So pushback reader class. So this is similar to that of your pushback input stream class. The characters that are read from the reader can be pushed back into the stream. This class extends the filter reader. So here we have already seen, when we have seen that pushback input stream. So it means that whenever I try to use my stream, in cases if I want to push back the data that I have read back into the stream, so then in that cases I can use this pushback reader, provided if it is a stream of type character. So now we have seen input streams as well as output streams. So in case of input streams, so we have seen various type of input streams that comes under your input stream classes. So whenever I want to read the contents based on the type of device I use, whether it may be a communication media, or whether it may be a device, or whether it may be a file, or it may be a directory. So in that cases, if I want to read from a particular device or a communication media, I can go in for using the input stream. So input stream handles bytes of data. So whereas similarly, if I want to write some contents onto any of these devices or any of these files, so in that case I use output stream provided my data is of type bytes. So we have seen input streams, we have seen about output streams. So this could be used in terms in case if I want to handle my data in form of bytes. If at all I want to handle the same data in form of characters, so in that case I need to go in for using readers and writers. So always I can create a communication pipe using my pipe input stream as well as my output stream. So based on the requirements of that particular application, I have to choose my input stream as well as my output streams that has to be used, or it should be readers or it should be writers. So again, whenever I use buffer, so whenever I read the contents from my devices, I use a buffer in the middle of my streams in order to buffer my data and then get the entire data till where I have to. So for example, if I want to get the contents till end of the line, just I can buffer it till end of the line and then I can read it. And then while handling my data, I should see to that whether the type of data that I am going to use comes under any primitive data type. If at all other than my characters or bytes, if I want to read or write my primitive data types, then I can go in for using my data input stream or my data output stream. If I need to use non-primitive data types, so then I cannot use any of these particular streams. So in that case, I need to use only the object input stream and object output stream. Anyway, that we'll be discussing on your next sessions. So whenever I have an application, that application what I am going to develop should use any of these streams, and again all these comes under your IO package, input output package. So here we have a set of exceptions also that has been available or given in your IO package. So your IO package has a set of classes and set of exceptions that are needed in order to do input and output. So till now we have discussed about your input streams as well as output streams, which could handle only the data type byte. Whereas if I need to access the characters in form of reading and in case of reading and writing, so then I have to use the reader classes. So we have just seen the hierarchy of the reader classes that could read your data in terms of characters. So and then your demo programs illustrates all the reading and writing process, even though we have not into all the methods. So we have seen only few methods that could be used. There are few other methods which could be used in order to read and write data in that appropriate streams. So you can just have a combination of these streams also. Anyway, in your next sessions we will also discuss about how to combine one particular stream with another particular stream and then access your data, that is read your data as well as write your data. Even then we have options to convert one format of your stream to the other format. So I can convert from a character stream to my byte stream to my character streams. Whereas in case of objects, entirely we have a different process called serialization, which could be used only in order to read and write your objects, that is all your non-primitive objects. So from this session we could be able to answer questions like various output streams, your various output stream classes and their hierarchy, and what type of data that could be handled using your data output stream. So what all data types that could be handled using your data output stream. So in your forthcoming sessions we will be continuing with all your few other reader classes and few other writer classes. Thank you.